sort of. Yeah, thank you. All right, this was actually our last presentation from our different 4 themes. What we will have now before we end today is that we will give the opportunity from our 2 winners from this year's innovation idea competition. And as most of you know, we have that as a yearly event. And this year we had almost 25 very good applications coming in. We had a jury who took out the 8 for this event matters most relevant cases, and from those 8 we had 2 winners, and one of the winners was RS Solution, and their project manager Jesper Martinsson. He couldn't actually be here today, but he sent us this video. Therese, will you please share?
Hello, my name is Jesper Martinsson. I'm very sorry I couldn't be there with you in real life, so you're watching this video. I'm going to talk to you about our innovation and our next step after winning this prize. Our innovation is absolutely essential in order to make deep mining possible. Without this innovation, deep mining will be very challenging. The end of deep mining is when ore turns to mineral, but when this happens and at what mining depth depends very much on our understanding of how deep mining affects the surrounding rock mass. To understand, we need seismic data processing. We need to detect, we need to locate and analyze every possible rock movement in the mine. And this is where our innovation, BEMIS, and our startup Rock Sigma enters the game. BEMIS is an innovation based on more than 12 years of research, mainly funded by LKAB and with results published in many of the world's leading scientific journals in geophysics. It is fully automatic compared with today's processing based on manual interpretation using cheap labor in different countries. Our innovation uses a unique self-learning algorithm that automatically adapts to the surrounding rock mass and changes with additional mining. Compared with today's processing, BEMIS gives orders of magnitude improved results. This is today's manual processing, where each dot is a manually located earthquake. We have the gray part here, which is this ground surface. We have the ore body in red and blue, so this is a side view. This is automatic processing with BEMIS. It gives 4 times more accurate locations. It reduces the processing time from 40 minutes to less than a minute, making instant evacuation possible. It also surpasses human abilities and can detect 6 times more quakes given the same data. BEMIS also has the unique ability to predict future quakes based on future mining. This means that mines can customize production plans to limit the risk of future quakes before they happen. It also gives us an understanding of how production, how the depth and how the size of the production affects the surrounding rock mass. Our innovation also has another unique ability that we think will revolutionize the way we understand how mining affects the rock mass. It can automatically create tomographic images of the rock mass based on rays caused by the seismicity itself. As with medical imaging, we can now slice the rock mass in different directions and really understand how deep mining affects it. Our next step will be focusing on future customers and give them the opportunity to test our solutions. We will strengthen our existing collaboration, and we will focus on making the first product. And this is where the funding from SMI will enter. We will use it to create a general prototype applicable to different types of mines with different methods, different types of induced seismicity, sensor configurations, etc. We aim to go from a technology readiness level of 5 to up to 7 using this funding. Thank you very much for listening. If you're interested in this or you have any questions, please contact either me or my co-partner Ville Törnman here at any of these addresses. Thank you so much for listening. Bye.
And thank you, Jesper, even if you really not can hear us right now. But I must say again, with the idea competition this year, I mean, we had 8 very relevant who competed on stage, even if it was digital, and the jury really couldn't take one out of it. So we had 2 winners, 600,000 each. We needed to extend the budget, of course, so you shouldn't share it. And the other winner was Hypex Bioexplosives, and with the project manager Thomas Gustavsson. And I see you here today, and we are very glad that you could be here, because we know that you have quite a full calendar.
Thank you so much. I'm very happy to be here, and obviously, since we had the chance to partake in the competition and win it as well, I must contribute back and tell you a little bit on what we're doing.
Thank you very much. The stage is yours.
All right. So let's see here. So my name is Thomas Gustavsson, and I am from the Stockholm-based company Hypex Bioexplosives Technology, and we are very grateful to be the second winner or sharing in the first place of this competition. And I'm here to talk about our innovation, why we are doing it, and what problems we are solving and how it works, and also a little bit on what we have in stock for the future. Hypex Bio is the first biodegradable and nitrate-free bulk explosive developed for the civil construction and mining market, mainly for the underground mining market. And the reason we have done this is mainly because of this problem statement. All bulk explosives used today globally contains mainly ammonium nitrate or other nitrate salts. And using ammonium nitrate salts and similar nitrate salts generate a lot of toxic gas pollutants. It generates nitrate leaching in groundwater, in ecological pollution. It is also very cost energy inefficient to produce ammonium nitrate, and it generates significant carbon dioxide emissions. We also have long-lived plastic post-blast explosive remnants, which is mainly ammonia, and all of these pollutants remained in the rock mass. Everybody involved in rock blasting understands the impact of nitrates in the rock mass and the impact of toxic fumes, especially underground. So, and the reason we have this problem is because we are using ammonium nitrate or nitrate salts as carrier of oxygen within the explosive matrix. So we have been working this problem and trying to find an alternative to this. Can we address this issue? Can we replace it with something that is equally safe, something that is equally effective in terms of blast performance, pull, fragmentation, and these things, cost efficient? It needs to be easy to work with, preferably work the same way as we do today or better, and use ingredients that are commercially available in the marketplace. And that is so we have a trustworthy supply chain to supply the enormous quantities that are used today. And we have identified hydrogen peroxide as an interesting alternative. Hydrogen peroxide is basically water with an extra oxygen atom, and we can use that extra oxygen to consume fuel in a combustion process and generate water, steam, and carbon dioxide. Basically, the process can be completely nitrate-free and generate fairly harmless gases, which is water, steam, and carbon dioxide. And we have done this in a water gel form initially. I'm referring to Tim Hunt, which talked about the water gel technology we started with, but we have also done it in a much more safe, reliable, and commercially viable form, emulsion. Due to significant laboratory and real production-like testing, we have now developed a stable hydrogen peroxide explosive which generates no toxic gas fumes at all. The remnants of the detonation are water steam, carbon dioxide. We don't have any nitrates in the emulsion, which means that we remove the nitrate leaching problem completely. Hydrogen peroxide is also more energy efficient to produce. We can use an electrolysis process to produce the peroxide, which leads to carbon emissions reductions of up to 92, even higher, 92%. Hydrogen peroxide is liquid, even in very cold temperatures, down to -4 degrees, which means that we don't need heating systems in the emulsification process. And that means that we can make very simplistic and very effective manufacturing processes, which are very small and cheaper compared to the status quo. We don't have any long-lived post-blast remains. We don't have the ammonia, and we can use fully biodegradable components. The best thing is it performs equally well as the status quo. And here is an example. To the left here in my picture, we can see the yellow toxic NOx gases, and to the right is a typical example of what you get with Hypex. And the future of this is to continue development and to continue develop other solutions like sustainable initiation systems, further develop the access to fossil-free sources, and expand the market to also offer packaged products and not only bulk, to continue to work in making the production process and the charging process more efficient to eliminate the greenhouse gases, also change characteristics such as densities to lower the consumption, and obviously trying to find business models to make the solution and delivery model more flexible. And this is my 4 minutes, so I thank you so much for your time, and we will upload this presentation on the site. Thank you.
Thank you so much, Thomas, and it's so impressive to hear what you have done. And when we have seen pretty much the whole day, combine innovation to push sustainable, efficient methods further. I mean, it's really brilliant. So yeah, we had a bit of a problem with our sound here. Did you say anything about if you already now can sell these solutions to any mining companies within Sweden or Europe?
Not yet. We are still building our factory capabilities, and we are very close to a full-scale verification project for one of the products that we feel we are ready with. And we also have a development program for some other iterations and some other product modifications that are in the pipe. We estimate to be on the market Q1 next year to supply the product to the market for a selected customer base.
Sounds super, and thanks again for attending here and sharing. And everybody, this was actually the last presentation for today. Jenny Greberg, our director, will you please come here as well? Because we, of course, want to say thank you to everybody. And I believe, Jenny, that you maybe want to hold a short summary.
Very short. I will not keep you longer. You've showed great stamina, I would say, to join us the whole day. And as always, it's so impressive to listen to and see all the fantastic projects that we have within this program. We talked about this during the lunch. It makes us really proud at the program office. We of course, we shouldn't be too proud because we're not doing the project, but we try to facilitate them and make them happen at least. So a big thanks to everyone who has presented and who joined us today. It's very valuable, and we are recording this, as you know, so we'll keep it for the future, and it's very good. And before I let you go, I would also like to thank my colleagues, and especially, you've seen Niklas a lot, but especially Therese also here in the background, who has been sort of the brain behind all of this. It takes some effort to make this happen also practically, and Therese has been our big support there. So thank you to Niklas and Therese and to the rest of the team, Lotta and Lawrence at Swedish Mining Innovation as well. And again, we're so happy and to be able to actually see so many great projects. Very happy and very proud.
Yeah.
So, and don't forget to hand in proposals for our next open call. You know, it closes 11th of November. And also don't forget the leverage call, the planeringsbidrag, if you're planning to apply for any EU projects or funding.
Perfect. Thank you very much. It's 14:40 and now 1, so we are over the schedule. Thank you and goodbye and see you later on.
Thank you.
Cheers.